So we have a nucleophilic addition reaction. Now we have an aldehyde, and this is treated with Grignard reagent. Ether is the solvent, and further it gets acidified. We are interested in products formed in this reaction. Now if you see the reactant, it has a chiral carbon. So this carbon is chiral. So for reactant, there are two stereoisomers are possible, and these two stereoisomers will be enantiomers. So basically for reactant, two enantiomers are possible. One will have plus optical rotation and another will have minus optical rotation. That is, one will rotate the plane polarized light clockwise and another will rotate anti-clockwise. Now let us say in this reaction we are taking one of the isomer so we have this compound. Now this is treated with Grignard reagent. Ether is the solvent. Now to derive the product, let us consider the mechanism of this reaction. In the first step, CH3 minus will attack on this carbon and this will open. So we will have this product. Now this carbon again becomes chiral. So basically this reaction generates a chiral carbon. So this carbon is chiral. So reaction generate a chiral carbon. Now the question is which isomer will be formed at this carbon, either plus optical rotation or minus optical rotation, or both will be formed in equal amount. This can be answered by looking the orbital picture of this molecule. So this carbon is sp2 hybridized and planar in shape. So if I show the same, we will have so this is planar. So this part of molecule is planar. So attack of methyl, that is CH3 minus, can happen from top face as well as from bottom face. So this is top attack and this is bottom attack, and these two attacks are equally likely. So we can say top attack and bottom attack are equally likely. So let us say if I write product after top attack, configuration of this carbon will remain unchanged. So let us call this is one carbon and this is carbon number 2. So we can say configuration at carbon 1 will remain unchanged. Now on carbon number 2, CH3 is attacking from top, and now we will have O minus and hydrogen. So this is top attack. Now if I attack from bottom, so that is bottom attack, this carbon will have same configuration. Now this time CH3 will be added from bottom. So basically at carbon 2 we will generate both configuration. So at carbon 2 both configuration will be produced. That is plus as well as minus both. So if I say for example this is plus, then this will be the minus. But at carbon number 1, whatever we have initial, it will remain unchanged. For example, if I have a plus, then it will remain plus. So if I initially take plus configuration of this compound, finally I will have plus configuration. So basically product is a mixture of diastereomers, now after acidification this O minus gets protonated and we will convert into OH. So this is after protonation. So after protonation, that is second step, after protonation O minus gets converted into alcohol. So in this reaction basically we are getting a pair of diastereomers. So optical rotation, if this has plus, so this will also have plus, and for example let us say this is plus, then this will be minus. This means I am getting plus plus, another is plus minus. So this denotes carbon number 1 and this denotes carbon number 2. So carbon number 1 has same configuration, but carbon number 2 has opposite configuration. So carbon number 2 has opposite configuration. So basically in this case we are getting a pair of diastereomers. Whenever we have a reaction in which initially reactant has a chiral carbon and this chiral carbon is not disturbed and we generate a chiral carbon in the reactant again that forms the product, then we will have a mixture of diastereomers.